Okay, so we found out all of our data last week, and now we are going to work on graphing it. The first thing we need to do is to fill out this chart with our interval and our upper bound for the cost and interval for the cost. So our interval for the year is fairly simple. We're going from 0 to 20, and we have 20 grids. So our interval is simply 1. Our upper bound for the cost we're left to figure out on our own. And what we're going to do is go back to our chart, which I don't have filled out here. And we're going to find the most expensive option. And it turns out if you look at your chart, that's going to be $28,000 for the full grid option after 20 years. Now, $28,000, just write that over here, is not something that you want to divide up into 20 pieces. So we're going to round that up. We can't round it down. We're going to round it up to 30,000. And our interval is going to be 1,500. And now we're going to label our graph. So down at the bottom, we have years, or rather time in years. And this interval is fairly straightforward, so I'm just going to label every 5. And on the side, we have cost in dollars. And this is less simple because our interval is 1,500. And I don't know about you, but for me, it's not simple to just say 3 times 1,500 plus whatever my interval is makes sense. So what I'm saying here is that I don't want to label it by 5s. This would be 7,500, because then it's not easy for me to immediately identify what this is right here. Because I'm not good at saying 3 times 1,500 plus 7,500 equals in order to come up with that tick mark in my head for every calculation I do. So instead, I'm going to label it by 2. So 3,000 here, 6,000. Okay, and it's important to make sure that this top one matches your upper bound, which it does. Okay, so we're going to start out by graphing our solar cost, which is $10,000 in years 0, 1, 5, and 20. It's $10,000 across the board. So we're going to find, first I'm going to give my key up here before I forget, solar. So I'm going to find 10,000 on my graph. That is closer to 9,000 than 12,000, but it's closer to the middle than either of them. And I am going to... Okay, I expect you to use a ruler, but that's really hard to do on... Well, I am using a ruler, but it's hard to use a ruler accurately on a device with a stylus. Okay, so that is our solar cost. I'm going to switch my color over to green for our grid cost. My first point for my grid cost is at year 0, I have spent $0. My second point is at year 1, I have spent $1,400, which is just under this intersection right here. At year 5, I have spent $7,000. which is closer to 6,000 than it is to 9,000, but it's closer to the center line, which is 7,500, than it is to 6,000. There we go. At year 20, I have spent $28,000. So year 20 is this final line over here, and I have spent 28, which again is closer to 27 than 30, but it's closer to the center line than to both of them. And now I'm going to graph my straight line. As you can see, it's not quite perfect, but that's okay. We'll learn some more precise methods of calculating this as we continue. Finally, I'm going to graph my hybrid cost in red. At year 0, we spent $8,000 on our hybrid system, which is closer to 9,000, but still closer to this middle line. In year 1, we spent $8,333, which is right about in the middle right here. In year 5, we have spent $9,650, which is right about there. And in year 20, we have spent $14,600, which is right about there. Going to draw our straight line. Okay, now your mileage may vary. All of these intersect at a very tight place. Right now, I'm more concerned about teaching you to read a graph than I am about precise and accurate data. We will figure out later on in this unit how to algebraically determine exact data. So we are going to leave this right here. Which model is the most expensive after the first year? We'll go back to our graph and look. In year 1, this is fairly apparent. Our blue line is the highest on the graph, and that is our solar model. Which is the least expensive after the 10th year. So we find line 10, we kind of go up, and our blue model is the least expensive after the 10th year. In which year are the cumulative costs of the full solar model and the full grid model the same? So it wants to know when solar and grid intersect, and that is right there, which is year 7. How does their cost compare after that year? Well, after year 7, we want to know how their cost compares, which is the grid cost continues to rise as the solar cost stays the same. I'm not going to write that out. In which year are the cumulative costs of the full solar model and the hybrid model the same? This is very similar. It's where the blue and the red lines intersect, which looks to be about year 6.5. Again, the hybrid model continues to rise right here as the solar model stays the same. Which model is most cost efficient over time based on this graph? Well, that would be the solar model. What are some additional factors that should be considered? Well, solar panels we haven't considered in this case do need some repair. We pretended that it was just a straight up $10,000 cost, but there are unpredictable repairs that come over time, such as hail damage. Some of those may be covered by insurance, some may not. Also, the effectiveness of a solar system drops slightly over time. So if you had a system that initially covered all of your energy needs, it may eventually you may eventually need to start paying off some of your energy with the grid because your system becomes less efficient. On the other hand, also many people have solar installations put in that cover more than their needs and are actually paid back by the energy company over time. So there are multiple factors in here that are a little bit more complex than just our simple graph. What are some ethical dilemmas that should be considered when promoting a full solar system? This is really important to consider because a solar system is expensive to install. So it's not really fair to go around telling everyone that solar is the way to go, because people might be really interested in this sort of low carbon energy, but they can't because they don't have the money to install it on their roof. So even saying that it's cheaper over time has no effect on anything if a person does not have the money to put it in up front. So what we're really saying here is, while solar is more cost efficient and is a great choice for people who can afford it, really we should be discussing this sort of dilemma with businesses who have a much greater ability to make a large impact, as well as the capital to make these sort of infrastructures, and the business sense to see that it is cost effective over time. Or we should be discussing having energy companies actually install solar on interested families, with the payback being over time at an interest rate. That would be effective too. Or even charging them the same amount as they do for regular energy, but allowing them to have the solar on their roof, because that way they know that they're being more carbon efficient. So these are all things to consider. There are other options for green energy as well, but again, most of them don't work as well on a residential level. They work on a commercial level, such as, for instance, wind turbines, and even more, for instance, nuclear energy, which comes with its own set of ethical dilemmas.